predominant issues that is grappling the entire world, and its impacts are not only felt by the polluting nations, but by everyone. At the international forum, world leaders are trying to negotiate and enter into international agreements to try and combat this menace, and have set national targets and they attempt to mitigate climate change. First degree from the University of Moratuwa. He obtained his master's degree from Postgraduate Institute of Management and his PhD from the University of Cambridge. After serving the University of Moratuwa in several capacities, Professor Diavis currently holds the position as the Dean, Faculty of Graduate Studies at the University of Moratuwa. Professor Diavis is a well-recognized environmental expert and has contributed to a number of locally funded and foreign funded environmental engineering projects. It is my absolute pleasure and honor to most cordially invite Professor Ajit Diavis to deliver the keynote speech in this session.
Hi, Boan. Good morning. First of all, let me extend my thanks for the invitation. Invitation extended to be present here today to say opening remarks for this session. Right, the session is pollution control, environmental health, and climate change. It's interesting when you look at the title that we are pressed by climate change. That means that in this 10 years time, whatever the decisions we make, either will make us or break us. And that's a no option scenario that we have been faced. And again, when you look at environmental health, we find we have also targeted so many things to be done to ensure that the environment that we are supposed to be living, I mean, like you manage the most existential threat that is a climate change. Again, the environmental side, we again have to take so many decisions to ensure. And of course, we have been traditionally looking at pollution control. And maybe that's what I want to raise, that maybe that we have to look at, considering that we are also an event organized by the Central Environment Authority and with a 40 years birthday, that we may need to revisit the way we try to attempt pollution control in meeting the challenges of today. And so just to recap, just to kind of identify things that have been happening, this decade should not give us any rest. Basically, this is a generation that we have to take serious committed action in order to ensure that we leave a planet or leave the system for the next generations to come. And so basically, you may not even have a decade. Some speak of like just 5 years, the decisions you make is going to be so critical. So we have the 17 Sustainable Development Goals in terms of making a future that is worthwhile. So those are like aspirational goals, but again, things like poverty and so on, it's all there in the agenda. More so with climate change, we are talking about this reducing carbon emissions, 50% reduction by 2030. Now that's a big challenge, right? We are talking about while the carbon emissions had overall grown, not reduced, even with COVID, there was a 70% reduction in the last year's assessment. And we speak of that it has to continue for the next decade in that manner. That is, we are basically in a lockdown mode to even to get into some decent position. Now we know that itself is a challenge because we are aching to get out and do different things or things that we have missed. So this is serious. And then we are also having the decade of ocean science declared because the oceans are getting basically affected, and we speak of 2045, more plastics in the ocean than fish and so on. And these are not just emotional qualitative concepts. They have been kind of quantitatively assessed to come up with these figures. So they are kind of real, and we need to pay attention to that. So the oceans paying a major service to the climate mitigation is really, we are also killing the oceans. And environmental health point, this also has been declared ecosystem restoration. And you can see this one challenge where we try to recover the systems that are getting degraded back into use. And one of the major things is through our action that we are probably creating the 6th mass extinction. And this has also been talked about. And from our own Sri Lanka, they have come out with Colombo Declaration for the Tackling Global Nitrogen Challenge, because we have been so concentrating on the carbon side of it. The nitrogen is also quite interesting. And this is not new stuff, but the only thing is we are kind of waking up to take action in this front fairly recently. So that is where the nitrogen challenge, that is again halving the nitrogen emissions, the waste, by 2030. Now that's another 50% reduction, right? And this is not simple. And that's when I said there's no chance to rest for us if we are to achieve something that actually enables us to survive and move to the future. So these are the challenges in a nutshell. Now, I would say that we need to look at, it's very important that we understand and base the policies based on science, and also our actions based on science. It's very important, and things are changing. So if I to take a story of the element of nitrogen, just to recap on how things have been changing in large scale, you move back into like 1905, where when the Haber-Bosch process came along, and it's a testimony to the fact that this changed the humanity in a major way, because that was a time we were able to harness the atmospheric nitrogen, fix it without the normal fixation by bacteria and so on the soil and the roots, but artificial synthetic fixation. So we had urea, right? And that's why the first company that did it actually still keeps a reactor on its front garden. And not only that changed that particular process of achieving urea, but it also heralded the high pressure processing for the humanity. That's the first time the high pressure processing came on, and today we know all it's about. But you see the repercussion of it in a sense that when you look at the world's population, you can see in the last 200 years and how this was picking up, right? The billions were getting added like very quickly. And these have become a reality because on one hand, things like this nitrogen fixation, and the other things like penicillin and so on coming for the treatment of infectious diseases. And still the workhorses in either in medical system or even in the fertilizer for the agro system. So you can see, but again, it's very clear when you look at the planetary boundaries that if you're talking about these biogeochemical flows, carbon, the nitrogen and phosphorus, specifically with nitrogen, we have now exceeded the planetary capacity. And that is, again, another quantitative assessment that indicates that we really are not doing right. So we need to probably innovate in the sense that we have been looking at this type of processing and taking for granted, oh, it's going to be available. Atmosphere has so much of nitrogen, so why not? But you can see that this situation is bad. But once you have captured, and then once you have this reactive nitrogen, the scenario is not just simple nitrogen. We have the systems converting to nitrous oxide, nitrogen dioxide, and all sorts of things. And then we have additional issues. Simply taking nitrous oxide, we are talking about a global greenhouse gas, and that is much more worse than carbon dioxide. And that is the root cause of the Colombo Declaration, right? But of course, this is again, as I mentioned, this is not new because Paul Crutzen came up with the Nobel Prize winning assessment for this nitrogen conversion. and this effect of biogeochemical flows. So he was really looking at the nitrogen cycle, and that happened in 1995, at the same year that the other two scientists got the Nobel Prize for the ozone hole concept, the identification of chlorofluorocarbons. But of course, we know that got priority, that received priority, and today we have nitrogen receiving priority, the attention that it is through the Colombo Declaration. So you see, these things are now demanded for us to change, and we need to understand that root cause of most of the problems that we are in, that is because we are having this conspicuous consumption. Somehow, this SDG 12 is about sustainable product consumption and production. And I'm not sure at all that we will ever get sustainable development unless we checked our consumption. So you say this, I'll just take it, thought of just putting the textiles, because that's a basic necessity. But are we only supplying, or are we only asking for our basic necessities, or have we really gone overboard on the consumption? You can see that from one side, the situation like the Rana Plaza when it happened. This particular image is very much made front pages about how people died, and it became a major industrial accident. Thousands plus died in that event, but it's because of you have to give new fashion, quick service, should not miss the season, etc., and you are pushing people to do things which you basically forego other things of doing business well or in a responsible manner. So that is because the consumption driven society that we are part of today. So we need to go from this conspicuous consumption to the conscious consumption. And you can see that, I mean, even if you take our clothing industry, it has come to the, after oil, this is the largest polluter in the world. And you can see we are really driven by fashion, and we don't want to wear the same thing twice and so on. And probably wear certain unnecessary things also, which and then we have, you can see the huge consumption, and then fashion thrives when you dispose what you are being pushed to dispose. So we have a very serious post-consumer stage. And again, on top of it, it's also one of the world's largest consumer of water. So you can have this conscious consumption has to come in. We should understand that this process is not going to be useful. So that's a big challenge. How are we to get out of our habits, and how do we transform our attitudes into this direction of conscious consumption? It's not that easy because we are quite getting used to this type of scenario. So while we look at the devil in our closet, it's also important for us to think, while we support the textile industry, if you look at the diagram on top, you can see that while we speak of pollution control, we speak of the industry in our economy. Though we are really running this industry, the profits are now happening at a completely different space in the value chain. You can see that factory running cost is not significant. Material costs are a sizable chunk, but in our case, it's a little bit more in the percentage wise because we had to buy all our material from outside and then add value. So we add only a limited value. Supply profit is marginal. Supply profit is really being pushed. You can see where the profits are in the brand markup, right? And you take even a t-shirt, your brand markup is the one that is really killing, right? And you will see in production, we are not making any money much, even though we speak of 4 billion, the garment the import income, right? The export income. So you need to be aware of this situation. And it is, when you think of brand markups and so on, you can see this, conscious consumption is missing when you have such value additions coming from a name and so on. Something to think about. We need to understand this reality. Again, with textiles, we forget, most of us, I'm pretty sure, forget that textiles are also plastics, and 50% of what we are wearing comes from like the polyester base. And today we have an emerging issue, which we look at as microplastics and nanoplastics. And we don't still have a solution to that. And now we even trying to look at scenarios like the new washing machines are coming out with filters added on, right? So this is really a big challenge. And when you amount to these nanoplastics, a microplastic becoming nanoplastic, you're talking about trillions of stuff. And interestingly, the Express Pearl is an interesting example. where we discharge about 10,000 metric tons of all types of plastics into the ocean at one point. And just imagine 10,000 metric tons breaking down, other than those that caught fire, into microplastics and nano. It's a huge issue, and we really do not have. And you can see this year's latest research, which is coming, first evidence of microplastics in human placenta, right? So we really do not know how things are moving around. At the moment, we are aware of they are migrating, they are moving around, but we do not know the end effect. You know, even if you take Minamata disease, the mercury was coming out of the factory, and it took 7 years for the first human casualty to emerge in the society. So it's a gap of 7 years. And in this case, we still do not know, right? And so we need to think pollution control in completely different way. We know pollution prevention is the best thing, not control, but we have to work with control. But again, in controlling, we probably need to think differently. So 2 things to highlight. I know this is a famous equation, the IPAT. We don't work on the population, even though nitrogen demands population change, right? Because nitrogen indicated the population rise. Something to think about, but we will not touch this point in the equation. We won't touch the point of affluence, even though that is what we addressed under conscious consumption, right? The grotesque bad affluence, the consumption is bad, but something we are not forcefully telling. But one thing we can work with is the technology, for sure, right? That is one thing we address, the IPAT equation, the T part, and we have green technologies. And on the other side, with chemicals and so on, which are the base of all things we do, we now try to work with the hazard being reduced and ensuring the risk is reduced as a result. Because the usual method in a factory is we understand the hazard as a permanent feature, and we don't work with the hazard. We accept the hazard and try to reduce the exposure, and thereby reducing the risk. That has been the standard practice, right? So we are past personal protective equipment and all sorts of things for the exposure. But we keep the hazard. Today, the challenge is, no, don't address the exposure to that level. Try to work with the hazard itself. And you have now the new subjects like green chemistry and green engineering to doing that. So I suppose if you have to drive these changes in the system, this concept of pollution control needs to change. And that's something I want to highlight here, just to in the short time period that's available. So we know that if you take our economy is a linear economy, right? So this is from Aruak Kalu. You will see the extraction stage that is happening. The mining is if you click, it's in the folder. It should be in the folder. It's connected to what's in the folder. Right. Anyway, that's the explosion. That just to demonstrate that we have extraction, and we are an extraction dominant. It was working. So the situation is for all what we use, that is this scenario. And you see that this is Sri Lankan picture, right? And for the basic production of cement, and it's a base material. But what we have been doing is we extract from earth and we discharge back to earth, and we try to push all of advertising, all our calculations of the standard economics is how to drive GDP. We are so happy talking about 7% GDP, and we see this value and get very excited about it, and we don't want a smaller figure to be identified. But what we don't understand is this figure comes with a huge burden in the current context. And it's so unfortunate we don't factor that even now. So we extract, produce, and push to produce and consume. And consumption is prodded to have enough and more waste to happen so that the process is energized to move in that direction. So this need to change. And that can be only changed by the way we work on, right? And we have this big argument today on energy to become sustainable energy. But we are missing the point that materials part. We can decarbonize energy, but we cannot decarbonize the material side. This is something that is not in the much of the discussion, right? Carbon cannot be taken out of the material cycle. We need to have it. So we need to bring the linear economy into a circular economy concept if we are to solve this as well. So the 21st century, this decade, demands this change. We all speak about much about the sustainable energy, but forget materials are so important. to run. Both these two factors are important. We have addressed one, but we are not addressing the other one seriously, right? So it's important that we work on this change of the economic method as much as quickly as possible. But we find overall in the world, you have a circularity gap concept being called, and it's about 9% is what we have. 90 billion extract, 9% recycle. You can see huge amounts either in use or in being discharged. And economies grows when you extract and use. So that's the normal thinking. So in Sri Lanka, even if the global average is 9%, Sri Lankan average at the moment, our calculation is giving up something like 3%. We have not calculated for the entire country. We have only done it for the Western province, right? So we need to change these business models of circulation has to come in. As simple as that, but it's simple on the diagram. So the philosophy is understood, but driving that has been very difficult. We must not have incineration. We must not have landfill, right? So the materials to go circular and no more extracts, things will go from cradle to cradle. It's ideal, but the point is it's doable to a great extent, and that reduces the pressure. So it's important. So you see these scenarios like Sri Lanka, in a sense, as an excellent example of, as I said, the textile. I take it again, the textile, because that's what I have put in for this presentation. We have this like world's best process for PET yarn to be recycled and so on. So you can see advanced ICT also being done. If I'm wearing the Sri Lankan t-shirt in Europe, I will see that these bottles came from the Bentara beach or something place. It's all given now, the traceability. And also you have techniques like trash to cash. I put my bottle and machine gives me cash to go and shop in that. So these are scenarios that have been made use of new technology. And only thing is we need it to happen more, and system should be supporting this. Countries still understood the value of resources like Singapore. They never had water. And just imagine a country not having water, having to buy material from Malaysia. Now in the top 10 of the global innovation and one of the top economies in the world, they have to drink the sewage, right? So you go to Singapore, we are consuming sewage. Of course, we recycle completely. And as a result, their technology is so good in the membrane processing. Now, that's the point. They were challenged and they did it. Long before we talk about circular economy, they had to, because that was the way they survived. And now the planet is being challenged to follow the same process, right? So we need to understand we had to change. So situations like nitrogen. And now in Sri Lanka, we have pollution control, but our biogas systems, when we have the emissions or the effluent, we are asked to control it back to the discharge limits. Something that need to be changed. The pollution control standards need to accept this recirculation part. And the most recent nitrogen depletion, the oxygen depletion zone has now come in the Bay of Bengal, which is actually equal to the land area of Sri Lanka. You can see that in the Bay of Bengal. So as we now still spend money on discharging to the ocean, other countries are using the sewage to drive buses and trains. And as I said, in Singapore, they are drinking the stuff. So it says the importance of nitrogen and the importance of the difference between the P and the poo has identified. So you can see the examples of use. So control now has to change to accommodate these circulating elements to be valued than meeting standards for energy discharge. So that's a major shift. Things like this, we need again to change, like our CEB need to change, that nitrogen recovery has to be supported. So like Biogas Italy, if you gives an additional amount of euros to a megawatt hour consumption, if the nitrogen is recovered to produce a fertilizer while the biogas is being produced. So that means the CEB and the agriculture comes together. And this has been discussing a long time, but in the circular economy concept, today's the way of running the organization is not right and need to change. Example, the final, probably in pollution control, we must not behave at Moratua, situation like we bring සිංහලෙන් කියනවා නම් අපි කොටන් ටික ගේනවා පුටු ටිකක් හදනවා ලොකු කුඩු ගොඩක් වේරස් ගඟට දානවා. That is our linear part, and 50% of the tree probably is lost, right? So we need to approve only systems, and we give EPL for an inefficient burning system for this thing. So we need to support things like this industrial symbiosis to ensure that Moratua become competitive. That is not just only the furniture industry, few furniture that is being made. You need to take this up from. So finally, let me end up with David Attenborough, who is now 94 years. And he says that he has seen across the decades, so many things. So instead of controlling the environment for the benefit of the population, which we have been doing, now maybe perhaps it's time we control the population to allow the survival of the environment. It has more than one meaning in that, but the point is there's a lot of truth in that statement. As I showed you with nitrogen and the population, as the challenges that we face, there's a lot of things to think about with this simple statement of David Attenborough. Thank you.
Thank you very much. That was our keynote address for this session conducted by Professor Ajit Diavis. Thank you very much once again, sir, for that very insightful speech. Just to give you an overview of how today's session is going to work, today's session will consist of 16 abstract presentations and 4 poster presentations. Each presentation will be 10 minutes in duration. At the end of each presentation, the panel will direct questions to the presenters, and in the interest of time, the question and answer session for each speaker will be 5 minutes. Before I proceed, it is my absolute pleasure and honor to introduce to you our most distinguished panel. Our panel chairperson, Professor Bandhuni Liyanage, Professor in Environmental Engineering, Department of Civil Engineering, Faculty of Engineering Technology, Open University of Sri Lanka. Professor Ajit Diavis, who is also our keynote speaker for today, Dean, Faculty of Graduate Studies, University of Moratuwa. Engineer M.N.R. Kure, Consultant, Environment Engineering and Industrial Engineering. Dr. Sanjay Ratnayaka, Deputy Director General of Environment Pollution Control Division of the Central Environmental Authority. And we will also be joined by Mrs. Devika Vitana, Director Compliance Monitoring at the Central Environmental Authority. We now move on to the very first presentation, abstract number 175, on the topic, phytoremediation potentials of water hyacinth for treating the cafeteria wastewater. We'd like to invite the presenter onto the podium.
Good morning, everyone. Today, I am going to talk about the phytoremediation potential of the water hyacinth for treat the cafeteria wastewater. My presentation line up with introduction, objective, methodology, result, and I will wind up with conclusion. Surface water resources in the developing countries are under very serious threat in terms of both quality and quantity. Almost 80% of the wastewater that we consume in our day-to-day operations and our domestic uses, that returns 80% of the supplied wastewater, domestic wastewater returned as a wastewater. In generally, generally activated sludge method used for treat the large volume of the domestic wastewater. However, the conventional activated sludge method not really helpful for remove the nutrients that contain in those wastewater. So several times I noticed that in the literature, there is some issue removing the nutrient from the domestic wastewater using the activated sludge process. So then I thought that there is another method for remove the, because then I decided to connect the activated sludge process and the constructed wetland system with the combination, and then I developed a small scale system for treat the wastewater. This is the small scale method that I use for treat the nutrient from the wastewater. So basically there is a lot of and several kind of wetland system we can found in the world, but I used very simple method, low cost method for treat the nutrient that contain in the wastewater. This is a floating aquatic microphyte constructed wetland system. For the floating microphytes, I used water hyacinth as my floating microphyte. Then there is several factors that affect to the efficiency of the wastewater treatment system. Among those factors, the hydraulic retention time is one of the most important factor that helpful for the efficiency of the wastewater treatment system. The hydraulic retention time is the average resident time of the wastewater that retained in the aeration tanks. Then I came to the phytoremediation. Phytoremediation is the nature-based solution that has the potential to provide the efficient, spatial, adaptable, and the multi-targeted treatment polluted waters using the ability to microphytes to take up secretes and degrade the pollutant. So there is several kind of phytoremediation techniques. For my case, I used water hyacinth as my phytoremediation technique. So then, actually, I used relative growth rate of the water hyacinth for calculate the potential of the water hyacinth. Then I related the relative growth rate and the potential of the treatment of the wastewater. So this is the equation that I use for the calculate the potential. Actually, I did several things during my research. I did removal. I calculate the removal efficiencies, and also I did some mathematical modeling for this. Actually, I already published those things, and this is the final part of that research. During that research, I developed the activator sludge process, activator sludge, and floating aquatic microphyte constructed wetland system with the combination of system, and then I calculate the pollutant removal efficiencies and the relative growth rate of the water hyacinth. System and the middle part of the system and the outlet of the system. Then I did the chemical analysis and then did the data analysis. Excuse me. This is my pilot scale reactor. Actually, I collect the wastewater from the Chiang Mai University cafeteria. In generally, 700 students use that, 700 to 1,000 students use that cafeteria for their day-to-day requirements. This is the small pilot scale reactor that I developed. This is the place I collect the wastewater downside of the oil trap, because when oil mixed with the wastewater, so it's going to be a disturbance to the system. So therefore, avoid the oil. I use the submerged pump to collect the wastewater, and then this is used as a aeration tank, small aeration tank with around 5 liter capacity. And this is a settling system. Use that traffic cone upside down. Then I send those wastewater to the small scale wetland. This is macrophytes that I use. And this is the place that I collect the university activated sludge system common wastewater treatment. This is the place I collect the bacteria to seed the system. Then I dried up all the, this is for the measure the relative growth rate. I measure the fresh weight and also the dry weight of the water hyacinth. And these are the methods, these are the analyses I did during my research. Right, let's move to the result and discussion. These are the result. During the, actually I already told that I carried out my research with 3 different hydraulic retention time. And these are the result I obtained during my research. For the fresh weight, actually one treatment I followed 13 days, and first day I measured the fresh weight, and after 13 days I measured the again fresh weight and also oven dried 40. Then I oven dried all the water hyacinth until it's getting constant weight, and then using those figures, I used to those figures to calculate the relative growth rate. So this is the graphical presentation of this relative growth rate for the HRT6. For the HRT6, the relative growth rate is 0.016 and 0.26 for the 12 and 0.15 for the 18. So you can see the HRT12 is the highest growth rate. So you can see the difference between the day 1 and day 3. So in the day 13, there is some necrosis found in the HRT6, but in the HRT12, there is a very nice growth showing the HRT12, and HRT13 also we can see very good growth on the water hyacinth, but the relative growth rate is quite low. This is the HRT18 difference between the inlet activated sludge process and after constructed wetland. So let's move to the conclusion. The highest and lowest relative growth rate of the water hyacinth are found in the 12 HRT and 18 HRT. But highest one found in the 12 HRT. The plant were dense in the growth and increased rapidly in the 12 HRT compared with the 6 and the 18. Leaf color is very greener and brighter in the 12 HRT. The lowest growth rate found in the 18 HRT because excess amount of the nutrient absorbed from the activated sludge process and not good enough nutrient that going to the constructed wetland. Therefore, no nutrient, actually very least amount of nutrient contained in the constructed wetland, and that's why it's the growth is quite low comparing with other 2 treatment systems. So this result showed that water hyacinth growth very rapidly in the polluted water, and it's make ideal candidate for large scale application for the nutrient removal in the water purification. So that's it. Thank you very much for your consideration.
Sir Madasa, okay, very interesting research.
Thank you.
Would you please explain me whether this is a batch system or the continuous system?
Sorry?
Batch or continuous? Because you
Continuous
feed one continuous system.
Continuous system.
Right, okay. So with that you are making this hydraulic retention time.
Yeah.
Right, okay.
So actually, I use the parasitic pump for control the flow rate and then differentiate the hydraulic retention time. First, I finish the 6 and then goes to the 12 and then goes to the 18.
Right. And also that what are the nutrient conditions like nitrogen and phosphorus? What are the concentrations?
Sorry?
Concentrations of nitrogen and phosphorus.
Concentration of nitrogen actually. Actually, I previously published those part. I couldn't include here, and actually I couldn't remember that concentration. However, nearly 2 to 4 milligram per liter, like that. Actually, I couldn't remember. Sorry for that.
Thank you.
Yeah.
The conclusion, the last conclusion, can yeah, actually, what is it is an interesting study, and also this particular observation is I mean, it's the correct thing. But how do you justify? How did you make that? That justification for that based on these figures only? Or?
Actually, for the thing is, in that case, I mentioned that quite greener than the 12 HRT and the consider with the other HRT. So actually, I did the visual observation for comparing with those things, and then I did not include that. Actually, I capture the photo from the leaf and then cut down into the 1 inches to 1 inches part in the computer, and then I measure the density of the picture. Then I found that the color density of those picture is in the HRT 12 is quite higher than the other two. That's why I told that it's quite greener. Actually, I did not include to here because I found the literature reviews that method is they did not use, but I thought that that method is okay for me, but I didn't include here because I didn't find any literature review in that method. That's why I did not include that. But I used that method to compare in the color density of the picture.
Simple question. Have you calculated the nutrient removal efficiency?
Yeah, I calculate the nutrient removal efficiency for the system. For the actually highest nutrient removal efficiency recorded in the 18 HRT. Nearly for the nutrient, nearly 89% of the nutrient removal efficiency. For the BO, actually all the parameters exceed nearly 80% of the removal efficiencies. For the highest, actually for the nutrient case, constructed wetland is act as a good treatment, good method for the nutrient removal. For the BOD, COD and other things for the activated sludge process.
Thank you. Quite neat. Just one comment. I like the one with the traffic cone with the using the traffic cone as a sedimentation chamber. But one quick, Sri Lanka has a specific water hyacinth law that has come in much early in like 1896 or something like that, early days, which prohibits movement of these weeds, right? When you take this into a pollution control type of thing, okay, it's nitrogen phosphorus control, the tertiary treatment, you will have an issue with movement of water hyacinth. So you are from Central Environment Authority as well. Maybe now you need to look at this type of ancient law, how suitable that is for this type of situation, and maybe look at it. That's a comment.
Yeah, okay. Thank you. Thank you, sir.
Thank you very much for that presentation. We move on to the second presentation for today, abstract number 238, the case study on the identification of the impact on wells along the coastal belt caused by the accidental onboard fire at MV Express Pearl cargo vessel. We'd like to call upon the presenter to the podium.
Good morning to you all. This case study, based on the conducted based on the accidental onboard fire at MV Express Pearl cargo vessel, recently happened in our waters. This study mainly focused on the identification of the impact on wells along the coastal belt from Usatakevo to Nigambo in Gampa district, considered as the highly affected by this incident. Introduction. This is the Singapore registered mercantile vessel. It had been on fire for 2 weeks. This is the place where the incident was happened. It's 9.5 nautical miles away from the coast near the port of Colombo. According to the Sri Lankan Ports Authority, the vessel had been carrying a consignment of nitric acid, bunkering oil, sodium methoxide, cosmetic material, methanol, vinyl compounds, and plastics as well. According to the sources, the consignment of the vessel was totally damaged by the fire. And also due to the huge fire, the gases and the particulate emissions were generated. According to this picture, you can see the smoke plume had been directed towards the land by the sea breeze. There are a lot of confusions among the dwellers and the environmentalists regarding this possibility of the wet or dry atmospheric deposition on land. Taking into account all these facts, the Central Environmental Authority involved the conduct in the case study along the coastal belt, collecting the water sample and further analysis. This is the methodology. This is the area selected concerned for this study. This is the road from Usatakevo to Nigambo. That's water samples were collected along the roads covering this area from 10 wells at the selected households from Usatakevo to Nigambo. Samples were collected 2 occasions. The first sampling was carried out 29th May 2021, and the second sampling was carried out 3rd of June 2021. The study focused on the determination of the physiochemical parameters such as the temperature, EC, turbidity, total dissolved solids, total suspended solids, chlorides, chemical oxygen demand, nitrate, and the phosphate as well. And also the chemical analysis conducted accordingly to the standard methods for the examination of water and the wastewater APA 23rd edition. Then the results were comparatively discussed with the reference data obtained from the previous monitoring studies, ambient water quality standards for category and Sri Lanka standards for the potable water. This is the first graph. This graph is given the comparison of average tested parameters, average concentration of the tested parameters in the first day and the second day samples. And the greenish line shows the second day samples, the concentration of the parameters in the second day samples, and the yellow line shows the concentration of the tested parameters in the first layer samples. And here you can see the very little change in the EC and alkalinity and the calcium carbonate between the 2-day concentration of the samples, but there's no significant difference between the when considered the other parameters also, there is no significant difference between the concentration of the tested parameters in the first layer and the second layer samples. Therefore, the average concentration of the average concentrations for of the tested parameters for 2 days were calculated to compare with the standards. This is the first graph, the comparison of the average concentration of the tested parameters in the first layer and the second layer samples, and with the average reference data. The reference data were collected from the previous study conducted in the same area, near the Jayala, and then compared with the concentration of the tested samples. As you see here, the EC is slightly below below in the sample concentrations, and also the slightly above in the alkalinity. The comparison between the average concentration of the reference data and the average concentration of the tested parameters in collected sample shows that the similar nature with the insignificant difference of the EC and the alkalinity. Results, and this is the second comparison. That's the comparison of the average concentration of the first and the second average concentration of the tested parameters in the first layer and second layer samples with the ambient water quality standard for category A. As you see here, still the sample concentrations are below than the ambient water quality standards for category A. Almost all tested parameters in the collected samples comply with the limits specified in the ambient water quality standard for category A, except slight exceedance of the COD. This is the third comparison of the average concentration of the tested parameters in the first layer and the second layer sample with SLS standards for potable water. And also the same nature, you can see the green line shows the SLS standards, and the purple line shows the average concentration of the first layer and the second layer samples. Here still that is the average concentration of the tested parameters in the collected samples with the permissible limits of the SLS standards, except little COD change. Based on the study, made the following conclusion. A significant change in the physical or chemically has not been taken place in wells, considering the coastal belt due to onboard fire at MV Express Well cargo vessel. And also following recommendations also made based on the considering the nature of my study. The study of the significant change in the water quality is extensively supported by the following recommendations. First, on the descriptive sample analysis, that is my study limited into 10 samples as well as the physiochemical parameters excluding the heavy metals. Therefore, it is recommended to include the heavy metals as well as more number of samples. Second one is a comprehensive set of baseline data in the locality. The baseline data also very limited. 5 samples used that was available in the previous study. So it is recommended another set of baseline data. Actually, more than 5 samples is better for the good comparison. And also the further extending of the case study in order to find the long-term impact. This study was conducted while the fire was going on. 2 days selected while the fire was going on in the sea, and therefore it is recommended to extend another sampling time for the to study in order to find the long-term impact of the wells along the coastal belt. These are the references used for this one. Thank you.
Much, Mr. Priyantha, for your interesting presentation. Maybe I'm a bit harsh, but would you please let me know that what kind of parameters did you expect to change due to this onboard
Yes,
fire?
that's basically we expected to some changes due to the atmospheric emissions from the fire, and it's
Yes, what type of parameters, what type of water quality parameters did you expect to change due to this onboard fire, the emissions?
specific parameters not considered, but just the wastewater, the parameters which is we considered in our normally in the potable water parameters we consider, because the well mainly considered potable water parameters, because the
Right,
we
thank
focus on the wells.
Right, okay. Thank you. The other thing is, would you please go to your presentation? One graph, just show me one graph. Yeah, okay. Okay, whatever the graph is okay. So, do you find any relationship in between those parameters, like that if you are going to have a continuous line, that you have drawn a continuous line in this diagram, right?
Yes.
The PHO, like a ECO, whatever the things. So if you are drawing a continuous line, then there should be a relationship in between pH and then the next parameter. But here we can't see like that. So therefore, next time when you are drawing this kind of graphs, please put kind of a column. Oh, you can't continue the lines, right? Okay, keep it in mind. Thank you.
Thank you.
Same concern that I also have, because sorry. Is that okay? Okay. Because probably the environmentalists and the dwellers are generally worried when things which has plastic material is burnt, because we have that experience even now. Burning of plastic is a problem. I think you know that. So people suspect that certain amount of like plastic material in the form of particles may probably SLS standard may not have dealt in detail. So what was in your mind? Did you predict any sort of did you predict anything like that? You know, maybe that vinyl or plastic material may get deposited there. Have you any prediction?
Just the maybe the form of particle, plastic material may be the form of particles or other gaseous emissions. So the when we study the TSS, we can understand sort of the deposition is there.
Probably
TSS is indicated that sort of the particulate matter.
right. Okay. But in this study, of course, the no detailed analysis of the TSS is done. So you just calculated whatever the total particle was, but not in detail. I suppose not. But you are suggesting it that it's to be done. Am I correct?
Yes, another sample time is there. Yes, another cycle of the samples.
Okay, right.
For the identification of the impact, long-term impact actually on wells. Because
Thank you.
Can you go to the first slide, Johan? Very first. When you see that picture, no,
sorry.
introduction.
First one, no?
Yes. When you see that picture,
Yes,
what comes to you in terms of potential pollutants that's going up? Knowing the cargo that's
Yes.
there, and it's a salty environment. And they're using seawater for firefighting,
Yeah,
boundary
yeah.
cooling.
The thing is that just I focused my study for the possible pollutants deposition through the emissions.
Yeah, I'm looking at the emissions.
Yes, that
But that's-
emissions. That's actually the materials are multidisciplinary, but I still that.
Can you think of something significant that may have happened? Should be
Yeah.
possible there.
The particulate matter mainly different with different chemical compositions, particulate matter.
But there were tons of polyvinyl chloride as well, PVC. And
Yes.
okay, then go to the okay.
The plastic
then go to
material
third
burning.
slide. The next one. Next one. That one. When you
Yes.
see the plume,
Yes.
right? It's coming because the wind was coming into the island. And then your wells, but what was the rainy conditions like? I mean, like conditions of rain.
Yes, the plume is coming the from away. The plume is starting from the
Ship and
ship
moving.
and it's moving. That is called dispersion is there. So
No, when you're
dispersion is
studying this
there.
area,
Yes,
and
that
the-
thing is I selected coastal area mainly. The reason is the concentration at that level is high and the dispersion may be become towards the
So any
land is
rainy
becoming
conditions
very
at the time?
diluting.
any rainy conditions at the time?
Rainy conditions in the first if they are pollutants, the first time will be deposition on the coastal area because the high concentration in the plume is there.
But if you have significant rain at the time, there would be significant dilution.
Maybe
So
the
when-
actually the rain condition was considered for here, considered in this study. Reason is the only the rain that deposition through the rain that deposition can happen there.
Yeah.
Changes in the water can happen through the rain.
But you don't mention anything about the rain. Rain can have a dry scenario.
Yes.
I mean, you can have dry deposition.
Dry deposition, both I consider reason is actually mainly that we have to consider
But
about
if you
the
have significant
wet
rain,
deposition.
you have a significant dilution effect here. And the point is that it is concluded that significant changes not been taken place in wells. Once you see a line like this, because you have not fully measured it, I'm like, I don't know, I'm asking the question, the potential dioxin and fluoride.
Yes.
What do you think?
Yes. Yeah. I mean, especially
Yeah,
we consider
yes.
the plastics.
That would be different when in the measurement. But anyway, when this sentence can be taken out, okay, there was no problem with this the ship at all. That's the point. But anyway.
So thank you.
Thank you very much for that presentation as well. With that, we move on to a short break from the session. We will be back with you shortly, so stay tuned with us.
දැනගන්න ඕනේ ඒක මේ
We warmly welcome you back to this session on pollution control, environmental health, and climate change. We move ahead with our presentations. Up next, we have a virtual presentation number 154 on the topic Sustainable and Conventional Washing of Denim Fabric and their Flammability Properties.
Assalamu alaikum and hello everyone.
This is Musitara Begum, a PhD fellow at Kaunas University of Technology in Lithuania, under the Faculty of Mechanical Engineering and Design. It's my great honor and privilege to take this opportunity to present my partial research work in this prestigious conference that is titled as Sustainable and Conventional Washing of Denim Fabric and Their Flammability Properties. We all are very familiar with the term named as denim and jeans because of their wide varieties of color and the washing effects or the fading effects. Those fading effects can be achieved by different kinds of washing treatments by using the chemicals. To achieve those washing effects on the denim fabrics in the ready-made garment industry sector, these days, denim washing has become a mandatory task. After making the denim garments from solid color from the dyed-yarn, the garments are washed by washing chemicals to modify the color and outlook of the garment. Apparent into this fashion is that it has been washed to achieve distinctive effects. Various types of denim washing processes are also used to achieve a soft and comfortable feel as well as a fading effect. Most of them, however, are hazardous chemical based. Therefore, the eco-friendly and sustainable garment design is the main challenge for the garment designers and the producers. However, all the garment designers and the manufacturers are now motivated to practice sustainability in their design modification as well as in the manufacturing processes. The initial objectives of this study was to achieve the same washing effect as previously attained by the traditional chemicals, as well as to replace the hazardous chemical from the washing process by reducing the water consumption in different processes during the treatments, to reduce energy consumption by recommending or using the low temperature during treatments, to reduce production time by minimizing the process parameters in the process timing, to make the washing process eco-friendly, and the last but not the least, by reducing the treatment cost. Current studies to make the same washing effects on the denim fabrics or the denim garment, the most popular or the used one is the potassium permanganate based washing chemicals. This potassium permanganate is an oxidative chemical that can be applied under acidic or alkaline conditions, and that can generate active oxygen and could make the denim fabric discolored. But of course, it is hazardous substance. Therefore, the eco-friendly sustainable garment wash is the new challenge for the garment designers as well as the producers. These experimental works, we have used the material as 1:3 2 structured fabric that is composed of 98% cotton and 2% elastane fiber. And the color was used as the dark blue topping color. That is a combination of sulfur and red dye stuff. Chemicals that has been used for the conventional washing treatments. And here, these are for the sustainable wash treatments. These all chemicals being used in these experiments are the industrial standard chemicals. And to apply this experimental trial, we completed this task in a denim factory in Bangladesh. Process. These are the list of operations as we applied for the conventional washing. That includes the desizing, decoloration, bleaching, neutralization, and potassium permanganate spray, again the neutralization and the softening. These all list of operations were summarized or designed according to the applied temperature and the time frame, as we can see in this figure. For the sustainable washing process, still we are following this list of operations that includes the desizing, decoloration, neutralization, spray, reduction stage, neutralization again, and then softening. These list of operations were also profiled according to the time and applied temperature in the process, as you can see in this figure as well. Completion of the washing treatments, we went through some physiomechanical tests as well as the characterization of those treated samples. For the physiomechanical test, we covered the color fastness to rubbing, washing, perspiration, as well as the tear stone test, pH test, the resistance to peeling, and the vertical flammability test. For characterization, to analyze the surface topography, whether there is any degradation happened in the morphological structure of the fabrics, treated fabrics or not. That was accomplished by using a scanning electron microscope test. And we analyzed or determined the chromium contents that is present in the treated samples. As we mentioned in our objectives, initial objectives, for the water consumption, we analyzed for both treatment, washing treatments, for the sustainable and conventional one. As you can see in this figure, the most consumable water volume was used in the decoloration step of conventional wash, while for the sustainable wash consumed a very negligible amount of negligible volume of the water for the same treatments. And we can see for the spray treatment, both washing process were using the very negligible amount. And we can see the sustainable wash, there is an additional reduction stage that has been added for the sustainable one, and that consumes 20 additional liters of water than the conventional one. At the same way, we can see during the bleach stage, we can see for the conventional wash, it is also consuming 20 more liters of water than the sustainable one. For the energy consumption, as we initiated to minimize the energy consumption, here we also can see for the first three treatment of the operations named as desizing, decoloration, and bleaching, all these three steps are completely omitted from the sustainable wash process. And definitely these three individual operations were consuming more power for the conventional one. However, the reduction stage is still consuming some power for the sustainable wash as well. For the color fastness to rubbing, as you can see, there is no changes happened or the negligible changes made for the color tint scale. But however, for the staining, we can see the poor weight rubbing results for both the sustainable and conventional washed samples. And it is to mention here that it is always challenging for the denim industry or the denim fabrics to achieve the better weight rubbing or weight staining results during rubbing compared to the dry one. Wash, as you can see, all the results for the color change as well as the color staining on the multifibers, all results are showing still the convincing, unless there is like the dark staining results can be seen in the nylon part, but still it shows the convincing and no significant change then to share. And for the color fastness to perspiration, it also shows there is no remarkable or significant changes between both treated samples. For the peeling and abrasion resistance test, according to the test method we applied, we have determined there was no washed fabrics or sustainable treated samples, both in the warp and wave directions compared to the conventional one. For the pH test, the pH reading on the treated samples were still in the neutralization stage, as we have applied a proper neutralization step during the treatments. For the surface topography analysis, here we can see both treated samples. We can see in this image that sustainable and conventional both were showing a remarkable gradation of the damage of the morphological structure of the fibers. Contents, we determine the chromium content among the treated samples as well as the raw one. Both treated samples were showing a degradation or like the less chromium content present in the samples. However, the sustainable wash ones reported the least contents. For the flammability test, we applied the vertical flammability test, but however, there was no significant changes were made between two samples compared to the untreated one. Here we can summarize the major findings of these experiments and of those experiments. As we can see, the sustainable wash that consumes less water and energy, that is 34% and 50% respectively compared to the conventional one. The color fastness to rubbing were relatively poor for both samples. The tearing strength was remarkably lost for the sustainable test samples, and the image, the ACM images were clearly evident that the damage of the morphological structure of the fibers and the least chromium content was reported on the sustainable wash samples compared to the raw and conventional one. Therefore, to conclude this study, we can say the eco-friendly washing chemicals can be used instead of hazardous ones to achieve same effect and obtain an excellent handle using a minimum quantity of water and energy. The denim garment required washing treatment to make it wearable, as we already know about. Definitely, this process will add value to the final consumer if this washing treatment follows the sustainable process. Though the sustainable process is eco-friendly, as we are highlighting about, but still it has some limitations on physical and chemical properties, as we have seen in the earlier slides compared to the conventional process. My sincere acknowledgement goes to my PhD host university, the Kaunas University of Technology in Lithuania, and of course the ICEZ organizers and reviewers for accepting my abstract and giving me this opportunity to present my work here today. Thank you very much, everyone.
Thank you very much. We'd like to thank that presenter for that presentation. Up next is oral presentation or abstract presentation number 166 on the title, Dispersion of Non-Point Source Pollutants Due to Land Use Change, a case study in Mathura City, Sri Lanka. We hand it over to the presenter.
Greetings to all. The title of the presentation is Dispersion of Non-Point Source Pollutants Due to Land Use Change, a case study in Mathura City, Sri Lanka. So this is the content that I'm going to describe the whole presentation: introduction, objectives, study area, methodology, results and discussion, conclusions, and final recommendations with references. So let's move with the introduction. According to Lapping et al. 2001, the land use patterns of a particular region is an outcome of natural and socio-economic factors and their utilization by man in time and space. The many studies have proved that during the last few decades, the increasing anthropogenic activities have largely impacted the land use change due to agriculture, forestry, water management, urbanization, and industrialization. In the basin, the land use changes influence the surface runoff, occurrence of flood situations, groundwater recharge, and transfer of pollutants. The water pollution can be happen in both point and non-point sources in both urban and urbanizing area. The point sources can be identifiable, but the problem in non-point source pollutant is it cannot identify like as non-point source pollution. The land cover related non-point source pollution is conspicuous with urbanization. However, the study on non-point source pollution related issues with urbanization is least studied in Sri Lankan context. Therefore, the study was mainly focused on land cover related non-point source pollutants accumulation with surface runoff. So the main objective is to find out the relationship between the land use changes with surface runoff and non-point source pollutants. The specific objectives were to prepare the land use map in respective years, to prepare the hydrological soil type maps in the study area, to estimate the surface runoff of the mother city, to estimate the non-point source pollutants of the study area, and finally to build up a non-point source pollutant index to the study area. So this is the study area map, which is situated in the southern coast of Sri Lanka. The annual precipitation is about 2,147 millimeters, and the average annual temperature is about 26.8 Celsius. So the methodology is subdivided into main 7 points: the preparation of the land use map, the preparation of the hydrological soil type maps, preparation of the curve number map. Number 4, estimation of maximum average daily rainfall for 100-year written period, estimation of surface runoff depth for 11 years. Number 6 is the estimation of non-point source pollutants in the surface runoff, and the final preparation of pollution index and pollution zone map for the mother city. So this diagram shows the way that we have conducted the whole methodology, which started with all primary and secondary sources and end up with the results. So let's move with the results and discussion part. Distribution of the hydrological soil types. The results prove that there were all 4 types of hydrological soil groups available in the study area. The study area was dominated by type B soil, and a few areas were covered by type A and type C. So the conversion of land use types of the study area from 1990 to 2020. When considering the year 1990, the dominant land use type in the study area was home garden type land. However, in year 2020, it was changed to the urban land type. When comparing the years 1990 and 2020, only paddy and marshy land types and urban land types show a positive change, while others show a decline. So according to the available equation, we estimated the average rainfall for 100-year written period. So the maximum average for 100-year written period in the study area was 69.55 millimeters. Rest of the slides are based on this estimated value. This slide depicts the transformation of surface runoff depth from the year 1990 to 2020. In here, only the category 41 to 60 millimeter is show or positive percent change of converted runoff area. In 1990, the most dominant runoff depth in category was 0 to 20, but when it comes to the year 2020, The most dominant runoff depth area was converted to 41 to 60 millimeter category. According to runoff accumulation volume, the total volume has increased in every year from 1990 to 2020. The highest total runoff accumulation was recorded in the year 2020. As a value, it was nearly 55,000 cubic meters, while the lowest is recorded in 1990. So this slide shows the locations where we collected surface runoff samples. Here you can see 35 location points. All the points are repeated by 3 times in different rain events. Collected runoff samples are lab analyzed and results were categorized according to the Sri Lankan environmental norms and ranked them to simplify the results. Using the ranked value, the pollution index were built, the index values were reclassified, and the pollution map was prepared. So here you can see the prepared pollution index map. In red color, you can see the pollution value in high areas, and in green color, you can see the low areas, and in the moderate area depicted in yellow color. So this slide shows the accumulation of different pollutants in different land types in different years. The highest total suspended solid has accumulated in the home garden type land, while phosphate and nitrate are accumulated in urban and paddy land type respectively. So let's move with the conclusions. The urban land area and the paddy marshland area are the only land types that show a positive change of conversion of land use, while all the land types show a negative change. The share of high runoff potential area and the share of the high runoff depth area in each year generally coincide with the share of the urban land area. On the other hand, the share of forest area in every year mostly corresponds with the share of the low runoff potential area and low surface runoff depth area. Most of the total suspended solid can accumulate in home garden type lands, and the majority of phosphate compounds can accumulate in the urban type lands, and finally, more nitrate can accumulate in the paddy or marshland type lands. So as recommendations, further studies need to be conducted to find the relationship between the rain event height and the rain event gap with the non-point source pollutants. This experiment can be expanded more by considering more pollutants such as lead, cadmium, zinc, copper, PAH, which are the most significant pollutants that rise with urbanization. Using a rain method that indicates the contribution of different pollutants to the pollution index could be more effective. And finally, collecting more surface runoff samples partially and temporarily can expand the exploratory topic. So here you can see all the references. And finally, thank you all for your kind attention.
We'd like to thank the presenter for that presentation. I believe the presenting author is with us virtually. If you can switch on your video and join for the question and answer session, we'd like to invite the panel to open the question and answer session.
Thank you very much, Mr. Gachanayaka, for your interesting presentation. It's really interesting because you have joined, or you have combined that the 100 years return period with the runoff as well as at the question is that when you are considering the 100 years return period, that you got that you found out the average daily rainfall is 69 millimeters per day. So how did you do this calculation? Very briefly, that I just want to know, because if it's a 100 years rain period, that the daily average cannot be 69.
Yeah, it's a simply statistical method which I use for all the calculations. So I collected data from the meteorological department of Sri Lanka, and using that observed
Presenter,
data.
I don't believe we can hear you. If you could adjust your mic settings, I think that would work better.
I hope you can hear me now. Hello?
Still unable to hear you.
It's unmuted.
Hello? 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 Hello, sir?
Increase
Can
your
you-
volume and your mic.
But the others can hear Mr. Gajanayak. I don't know for the camera.
Hello?
Presenter, I don't believe we can still hear you, but we have a comment that the others can hear via Zoom.
Microphone volume.
Presenter, we'd like if you could test the mic once
Yeah.
again.
Hello? 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 Hello?
when we connect you properly, right? Thank you.
Thank you.
The rubber sector in Monaragala district in Sri Lanka.
In the smallholder rubber sector in Monaragala district in Sri Lanka. I am Sanjeev Gundan from Rubber Research Institute of Sri Lanka. From University of Sri Jayawardhanapura, Professor Jagat Pidri Singh, University of Wayanad. Layout, introduction, research questions, objectives, methodology, results and discussion, conclusion, acknowledgement and reference. Sector plantation crop in the Sri Lanka. According to 2020 figures, their GDP contribution was 0.3% to the country. When we look at the rubber smallholder sector, it plays vital role in the rubber sector. Around 150,000 smallholders are functioning in the country in the 16 administrative districts. We followed the recommendations of standards. Then stands of the wood, then small. Stands introduced to prevent the environmental pollution, especially in the air pollution. Not only that, so the farmers are not using those types of stands. What happened? Then they used more and more firewood. Not adapting those stands of the smokehouses. What are the factors affecting the adapting of the smokehouses? Finally, what are the strategies for enhancing the improvement of the adoption of the smokehouses? Under this research questions, research distribution of factors on the level of the smokehouses. Finally, what can we do to develop the strategies for accelerating the adoption of stands of smokehouses in the smallholder sector in Monaragala district? Research methodology. Random sampling technique, 108 rubber smallholders with smokehouses. Monragal district. Data collection and data analysis. Key information of the rubber smallholders were taken. Then level of the adoption in 5 critical, as I explained earlier. Then the 5 critical areas of the smokehouses, stands of the smokehouses recommended by RRISL were measured as using by the adoption scale as adapted or unadapted, not adapted. Then finally, reasons for the deviation from the standards of the smokehouses were recorded and finalized. Then primary and secondary data were collected with the field level observation. Pre-tested household questionnaire survey in 2019 were done. Finally, descriptive statistics and experiment correlation analysis were used by Stata 14 software. And was prominent. That's tertiary level education was 8%. Then the average experience of the rubber smallholders around 11 years. Then average capacity kilograms per day. Of stands of the smokehouses. It's very pathetic situation actually. Then you can see here ranking system adaptation is somewhat high, around 62%, but others, smoking channel, air circulating halls, ceiling roofs, they are below the 25% of the adoption rate. It's very poor in Monoragala district. So why people are not adopting those stands? Actually, they mentioned they are not aware about those stands. Then you can see here clearly. So then roof, ceiling, air circulating, those systems have very low level of awareness. Between personal characteristics of the rubber smallholders and adoption level of the stands of the smokehouse. And that's 0.5 level. But education is positive correlation. Then rubber farming experience has a positive correlation with the stands of adoption of the stands. Then membership, participation in training program, memberships in these rubber societies. Then advices given by the extension class. These are very critical factors. Those are positive with the adoption of the stands of the smokehouses. That's why these are very important for the policymakers. Adoption rate of the finally, we can conclude like that, so that adoption level of the smokehouses stands in the Monoragal district was very poor, according to the analysis result. Then we have to enhance in the adoption of the smokehouses stands by the rubber smallholder sector. How? By using training programs, awareness programs, by using mass media, establishing models like that. So then to produce those things, so extension services, especially in the rubber development department, Rubber Research Institute of Sri Lanka, and private sector, those who are involving in the extension organization in the Monoragal district, play a vital role to enhancing the adoption rate of the smokehouse stands to prevent the environmental pollution, especially in the Monoragal district in Sri Lanka, in the smallholder rubber sector. To the rubber smallholders in Monoragal district for their valuable support. Thank you very much.
Hello. I can't hear you. Hello. Hello. Hello.
Yes? No.
Hello. Can you hear me? Hello.
Hello, Mr. Gunaratna?
Yes.
Okay.
Okay. I am okay. Yes.
Right, okay, thank you. Would you please let us know that what are the recommended standards that you expected from these smoke houses? We're
Yes.
talking
Here.
about recommended standards, but you have not mentioned those.
Yeah. Here, during this study, we considered only 5 recommended standards: ceiling, roof, then racking system, then hauling system. Sorry, those things that they are. You are asking that stands.
Yes, because you haven't mentioned those things. What are the standards that you are expecting?
Yeah, they are. Here it concerned the one-day drying systems. So that stands means that they are dimensions especially, and the roof height, then the roof width, then smoking channels height, then width, then type of the ceiling pattern. Those are depends on the capacity of the smoke houses actually.
Thank
So
you. My next question is that have you measured the emissions from those smoke houses?
No. Here, under this study, we didn't measure the emission parameters. But here we know that RRISL recommended the stands for the particular smoke houses. But in the field level, most of farmers, especially in the Monoragal district, this is the non-traditional rubber growing areas. They did not adapted that recommendation. That's why we focus to why. What is the reason for that? Then.
Right. Thank you for that that answer. My next question is: you are in your title. You are mentioning that to prevent environmental pollution.
Yeah. Yes.
Yeah. If you are not that whether environmental pollution is happening, that how you are talking about the that regarding the preventing.
No. Yes, pollution is happening now. Normally, our most of the smallholders build their smoke houses very close to their houses. That their smoke channels, emission channels are sometimes most of time close to their living houses. Not only
So
that.
Talking about kind of indoor air pollution due to the smoke houses.
Yeah.
Right. Okay, thank you. Thank you, Suratna. So I'm going to ask from the other panel members to get question from you.
Okay, I will ask. I have two questions. One is, I can't understand why now you say this is a new initiative in the Monragala district, right?
Yes.
And you have been able to get the rubber tree that part to the field, but why you have failed in getting the technology of the smoke houses also at the same time, because they're new to the whole thing. So why part of the package has reached the farmer, not the full process understanding? And the second connected is who manufactures and give this? Are they kind of like they're doing their own way? Is that one of the reasons that it's they are having different practices? Somebody is fabricating these and giving them, or just they are doing it by themselves?
Yeah, actually, most of all of the smallholder rubber farmers, they produce their own product. It's called as ribbed smoke sheet rubber. but few people are producing, not producing the RSS, but they sell the raw latex. So then initially under the rubber expansion project, so basically we introduced that standards, and then we did the most of awareness programs and training programs. However, that then after that, after a few years, not a few years, after 5-6 years, so then when we go to the look at the field level, so that we have seen that situation. That's why we focus this study. What is the reason for that? People are not adapting those measurements which are affected to the
I do not.
environmental pollution.
If you have a mechanism of somebody doing the smoke houses and selling them to be installed, you probably have a solution.
Sorry?
Maybe the out.
Pardon? Hello?
Hello?
Hello? Hello?
You hear?
Yeah,
You
yeah.
can hear?
Yes,
Okay.
I can hear.
No.
Yes, please.
Question was if you have producing the smoke houses at some point and giving those to the farmer, that may be the way out, because it looks like that they are doing it their own way, and that is the reason maybe for the failure. Just after listening to you, and I'm just thinking, because Monoragal, the whole process being new, I can't understand why they do one part in the way that you want and the other part is not happening the way you want.
No. Then whole process is advised by the extension organization, especially in the Rubber Research Institute, Rubber Development Department, then through Sayo Foundation, like that organizations, especially in the public sector. So that, but then due to the various reasons, but it may be lack of human resources in extension sites like that. So however, then those organization introduced and they give that they are our requirements. Those are the requirements to be built in the smoke houses. But the thing is, then sometimes then extension people can't go to always can't go to the observe and give the advice, those things. That's why then it also may be the one of the reason. But we introduced that packages and then those things. But there's a thing like that happening.
Panel, I believe the question and answer time limit for this presenter has been exceeded. So we'd like to thank the presenter, and we now move on to our next presentation. I believe the presenter is here with us virtually. We move on to abstract presentation number 95 on the title Colloid Stability in Chemically Heterogeneous Soils, with special reference to a CKD-U prevalence area in Sri Lanka. We now move on to the presentation.
From Faculty of Engineering, University of Peradeniya. I am here today to present our research study on colloid stability in chemically heterogeneous soils with special reference to a CKD-U prevalence area in Sri Lanka. The other co-authors of this study are Ms. P. Balakrishnan and Dr. T.K. K.C. Deepakuda. This will be the content of this presentation. Moving into the introduction, as we are all aware, the CKDU problem in Sri Lanka, especially in the North Central province, can be identified as the most significant non-commutable health concern for the last couple of decades. Authentic statistics reveal 8,000 CKDU patients in Sri Lanka in 2012, and studies estimate more than 30,000 patients by 2017 in the North Central province, knowing the fact that its prevalence remains mostly underreported. Currently, over 150,000 people are affected by the disease, and about 3% of them lose their lives annually. Despite extensive studies carried out from various perspectives, no conclusive causative factor for CKDU in Sri Lanka has been characterized yet. Due to its inherent complexity and scientific ambiguity to pinpoint a single cause, many studies hypothesize that the problem is of multifactorial origin. However, many researchers suggested the problem is associated with drinking water and presence of various contaminants such as agrochemicals, heavy metals, etc. Could be a potential reason for CKDU. Then the question arises how these contaminants can potentially transport through the subsurface and end up in groundwater. Several mechanisms can account the process. Some of them are advection, dispersion, and diffusion. However, one such hidden, largely underestimated mechanism can be identified as colloid facilitated transport. Colloids can be identified as the particles with the size in range of 1 nanometer to 1 micrometer. Since the particle size is really small, they have a large specific surface area and also a high surface charge. Due to these two attributes, colloids can soak chemicals with high affinity and carry them to groundwater through the subsurface by this process. This colloidal phase is a hidden mobile phase in a soil water system as shown in this figure. And the mobility and the transportability of colloids and contaminants are highly sensitive to physiochemical properties of soil and especially the stability of colloids. Now let's see what is known as colloid stability. The stability of a colloidal system is defined by particles remaining suspended in solution and depends on the interaction forces between the particles. If we consider a colloidal solution is stable, it means the colloidal particles will repel or only weakly attract each other and the substance will remain a suspension. The dominant factors which can affect the colloid stability are salt concentration, ion valence, and pH. DLVO theory represents the understanding of interactions between colloidal particles and their aggregation behavior. It's a theory of colloidal dispersion stability in which zeta potential is used to explain that as two particles approach one another, their ionic atmospheres begin to overlap and a repulsion force is developed. Zeta potential is a scientific term for electrokinetic potential in colloidal suspensions. The figure shows the zeta potential for a particle in a dispersion medium. The aim of this study is defined as to investigate the colloidal stability of two soil types which were collected from affected areas of chronic kidney disease of pulmonology regions in North Central Province, Sri Lanka. Objective 1 is to investigate the effect of pH for the colloidal stability. Objective 2 is to investigate the effect of ionic strength for the colloidal stability. And the final objective is to numerically characterize the colloidal stability in soils. This slide shows the sample collection areas in Anuradhapura district map, Medavachiya and Horopatana. Medavachiya is considered as a highly CKDU affected area and Horopatana is considered as a relatively low endemic area. Samples were collected to the core barrels as shown in this figure. And then to prepare the colloidal solution which used in the stability experiments, this procedure, the shown procedure is followed. First, soil were dried and crushed, then sieved by 2 mm sieve. Then 150 grams of sieved soil was mixed with 1 liter of water and shaken for about 15 minutes. And then it was kept undisturbed for 20 hours. And the particles of stalk diameter, which is less than 2 micrometer, was siphoned. This extraction depth H was calculated using the Stokes law. After making the colloidal solution, They were taken to 1 liter beakers and pH was adjusted as 3, 5, 6, 7, 8, and 11 using sodium hydroxide and nitric acid. Similar pH solution series was prepared for low endemic soil as well. Then the turbidity variation was investigated in the colloidal suspension in predetermined time intervals. Similarly, to examine the effect of ionic strength, colloidal suspensions were prepared by varying the NaCl concentrations as 0.01, 0.05, 0.1, and 1 m for both soil types, and the turbidity variation was investigated in predetermined time intervals. This figure shows the stability experiments for 2 scenarios with adjusted ionic strengths. Then the results were plotted with time. The obtained experimental values were then numerically modeled using an exponential parametric function. The turbidity of the solution Nt at given time t can be written as this equation. Here, Nt is equal to infinity is the turbidity of the colloidal solution after infinitely larger time period. Nt is equal to 0 is the initial turbidity of the solution. T star is the characteristic time at which the turbidity of the suspension is dropped by 90% of its initial turbidity. And P is the shape factor which accounts for the curvilinearity of the curve. This slide shows the experimental turbidity values and the simulated curves for high endemic and low endemic soils with adjusted pH. As you can see from the graphs, at higher pH values, soil colloids exhibited higher stability against coagulation and flocculation. This could be due to the increased electrostatic repulsion. Because in higher pH values, sodium plus and hydroxyl ions in the solution is also increasing, leading to more repulsion between ions and the negatively charged colloids. This slide shows the experimental turbidity values and the simulated curves for high endemic and low endemic soils with adjusted ionic strengths. As you can see from the graphs, enhanced colloidal stability at lower ionic strength for both soil types were observed. This could be due to the addition of salt, which weakens the particle-particle and particle interface repulsive electrostatic forces. This may lead to destabilization of the suspension at higher ionic strengths. This slide shows the pH variation curves which were generated using the developed exponential parametric function. The left side figure shows the figure for high endemic soil and the right side figure is for low endemic soil. Finally, let's look into the numerical modeling which was done using the DLBO theory. The total interaction energy could be written as the summation of van der Waals forces and the AA interactions as shown in this equation. Here, H is the Hammaker constant, sigma plus and minus are the surface charge densities per unit area. Epsilon naught is the permittivity of vacuum, epsilon is the dielectric constant of water, and K is the inverse Debye length. The figure shows the typical diagram of the interaction energy with double layer and the van der Waals forces. The total energy was calculated for 2 ionic strength values to examine the effect of ionic strength to the interaction energy. 0.01 m and 0.05 m sodium chloride concentrations were selected in this purpose. And as you can see from the graphs, the variation in ionic strength did not much affect the van der Waals forces, but it directly affects the AA interactions and hence the total interaction energy. So according to the results obtained from this study, it can be concluded that at higher pH values, soil colloids exhibited higher stability against coagulation and flocculation. Enhanced colloidal stability at low ionic strength was observed for both soil types. The developed numerical model could adequately describe the observed colloid stability with time with the optimized model parameter T star. Ionic strength did not affect the van der Waals forces, and ionic strength directly affects the double layer interactions, hence affects the total interaction energy. Here listed are the references that I have followed. Thank you very much, and I'm happy to answer any questions. Sorry, I can't hear you. I'm sorry, I can't hear.
Able to hear us, presenter?
No, it's fine. No, again, I can't hear.
Hello?
No, it's fine, madam.
It's echoing. Hello, can you hear me
Yes,
now?
yes, madam.
Right. Thank you for your. I had a small technical issue. Can you hear me?
Yes, madam, but there are disturbances.
Yes, Miss Gunardhan.
And answer session. So please bear with us. We will move ahead with the presentations for the time being, after which we will come back to the question and answer session from the respective speakers. We value and we appreciate your patience. Up next is presentation number 252 on the topic investigation of carbamate byproducts in leachate of solid waste dumps. We'd like to invite the presenter onto the podium.
landfills and remain for hundreds of years. And environmentalists have recognized this as a major issue. Even though these polymers are considered to be non-toxic as long as they remain as a polymer, landfill accumulation can cause the leakage of toxins into the environment as time passes. When these polymer wastes are disposed into the environment, they can be exposed. When these solid wastes are disposed into the environment, they can be exposed to various environmental conditions, pH variations, and chemical reactions as well. So these polymers can be lead to the breakdown of the polymers and resulting in byproducts. And some of these byproducts are considered to be harmful materials. According to the previous studies, there are no proper methods to investigate or test the carbamates which has a possible leaching from the polymers when they are dumped into the solid waste dumps. This research was conducted to fill that gap. The polymer that I have used in my research was polyurethane foam, which is the reason for using this polymer is because it is one of the most conventional polymer used in Sri Lanka. Polyurethane is a polymer which is composed of organic units with a carbamate bond. And this polymer is synthesized industrially by the condensation of polyisocyanate and a polyol. And this is hard to break down. Polyurethane wastes are either municipal or industrial. These wastes are disposed into solid waste dumps or incinerated. However, this incineration process is an incomplete combustion process which can produce the product which can lead to the production of poisonous gases and hazardous chemicals. Therefore, this polyurethane recycling is much more difficult and an energy intensive process. Previous studies have shown that polyurethane recycling using the natural conditions is much harder and physical conditions is much effective in the short term. And also previous studies have shown that the polyol is problematic because it's petroleum based and not readily degradable. Therefore, they have found a method to change to chemically change the structure of the polyurethane polymer, and they have found a solution for the polyurethane waste problem. However, there are no proper method to recycle the large quantity of polyurethane waste in Sri Lanka. Therefore, they have been disposed into solid waste dumps. Since we have identified the need of a proper method to test the possible leaching of carbamates, byproducts from polyurethane polymers into solid waste dumps, we were searching for a method to test this leaching and also a method to identify the leached carbamates in solid waste dump sites. Therefore, we have found that spectroscopic application methods were the best option. Initially, this was the plan to carry out, mainly using the HPLC. Since it was hard to find the standards for carbamates, we had to digest the polymer using the acid digestion method and microwave digestion method to obtain monomers and dimers. These products were analyzed using the FTIR and TLC plates. In the acid digestion method, two methods were carried out. In the first method, sodium carbonate was the catalyst. In the second method, zinc acetate was the catalyst. In both methods, ethylene glycol was the solvent. In microwave digestion, I have used 4 methods under different conditions. In the first table, you can see the 3 conditions that I have used in microwave digestion method. After digesting polymer, the mixture we obtain might contain more than 1 byproduct. Therefore, we have to do a separation. TLC plate separation was carried out to find the suitable mobile phase. And in the second table, you can see the mobile phases that I have tried out. From this, you can see the results that I have obtained after analyzing the product of acid digestion using the ATR FTIR. You can see that both spectrum are more or less the same. And this analysis was done just after the digestion as well. And also, initially, to digest this polymer, we have had some chemicals. And also the mixture after the digestion, the mixture we obtain might contain the chemical starting materials as well. Therefore, these results were not adequate enough to conclude that the mixture we have obtained after the digestion contain only the byproducts. This is the thin layer chromatography results by using the iodine bath and the fluorescent lamp. You can see that there were no clear separation of the compounds. Therefore, this method was not a success in separating the compounds. Since this method was not a success to carry out this research furthermore, we moved on to a model study. In this model study, we accelerated the leaching process, which are believed to take place in solid waste dump sites. And in this model study, the polymer was dipped in solvents, aqueous solutions of different pH values, 2, 4, 9, and 11. And these solvents were kept inside a temperature control chamber for 50 days at 45 Celsius degrees. After 50 days, using the same chamber, each solutions were dried on clean glass plates, and these glass plates were analyzed by using the ATR-FTI. In the meantime, the pH of each solutions were measured within 1 week. This is the circuit of the temperature control chamber. In the power supply, alternating current was converted into direct current and the output is 12 volts. From this, 12 volts was supplied to the temperature control module, temperature sensor, and the fan. And the temperature of each solutions were maintained at 45 Celsius degrees. A polystyrene box was used as the chamber. This compartment contains the power supply, temperature control module, and the relay circuit. In the right side, you can see the incandescent bulb, which was fixed to the top lid of the polystyrene box. In the left side, in the right side, you will be able to see the Bose heads I have put inside the chamber to hold the heat for a longer period of time. From this table, you can see the pH fluctuation within 3 weeks. In pH 2 and pH 4, the pH fluctuation was negligible. And whereas in pH 9 and pH 11, the pH was drastically changing. The reason can be due to the degradation reaction that has taken place in basic solutions at higher pH values. However, in the first spectrum, it represents the pure polymer spectrum of the pure polymer, and the main peaks represents the main functional groups of the polymer. The other two spectrum shows the ATR-FTIR spectrum of pH 2 and pH 4. As you can see, there are no significant peaks, indicating no leaching from the polymer in these solutions. However, in pH 9 and pH 11, you can see that there are main peaks, and these additional peaks can be represent the possible leaching of the polymer. However, since there were no standards to identify these byproducts, further studies can be done to identify these byproducts. Let me conclude my presentation. The results obtained indicates that polymer is leaching at higher pH value as smaller fragments, and increased temperature enhances the leaching of the polymer, which usually takes a longer period of time at environmental conditions. pH of the acidic solutions remain more or less the same over time. pH of basic solutions decreased over time. Since the degraded polymer samples and the leachate can be complex, the identification separation method required advanced analytical techniques. Thank you.
Siri, thank you very much. Okay, interesting presentation and interesting topic also. And from your research, that you conclude that no carbamate is coming from the dump sites?
No, since we couldn't find the standards to identify those byproducts, we couldn't tell that this is exactly carbamates, but we can conclude that there is a possibility of leaching out from these polymers.
Under what conditions that the carbamates can come out from the leachates, from the dump site through leachates? under what conditions that you expect that carbamate can come out from the dump site?
From the dump site. Because of they are exposed to extreme conditions and they are remain for hundreds of years in solid waste dump sites. So
But what do you mean by the extreme conditions? That's what my question.
yeah. So they can be exposed to rainwater and sunlight as well, and in the solid waste dumps there are more chemicals as well, so they can be interacted with those, like do some reactions. There is a possibility of doing some reactions with other chemicals that are dumped into the solid waste dumps. So because they are not individually staying in the dump site, they are interacting with other substances as well. So there is a possibility of leaching out because of these reactions.
Okay, thank you.
Thank you for the presentation. I think it's very useful one. My questions are one of the assumptions. You have said that the polymers are considered to be non-toxic as long as they remain. What made you say that?
That's because I said it because the polymers are considered to be more stable because of the bond they are having, and because of the carbamate bonds and the linkage bonds they are having, they are more stable. We consider that. But when they are exposed to the environment, they can release units which they are composed with. So that's why I explained it like that.
Other thing is now when because you are considering solid waste dumps, did you find out, or did you try to find some sort of a composition of plastics, composition of polymers in a dump site? Now, when you get a dump sites, now there are studies of like what is the composition, like constituents, especially with regard to the polymer content like plastics and others. Did you like find out what is the percentage of different constituents in the
What are the other polymers?
yeah, for example, in a dump site, you might get polyethylenes, polyurethanes, okay, and even fiberglass like that. So, did you like came across any composition, or you measured it?
I couldn't measure it. Wow. Please explain me if I'm wrong. I think you are asking is why I choose polyurethane.
Yeah, because you have said that polyurethanes are one of the most conventional plastic materials found here.
That's because since polyurethane have it's composed with it's a block polymer. Therefore, it has a large variety of properties, and they are used to do manufacture many things in the world. So I in research articles also I have seen that they said it's a conventional plastic in all around the world, because they are used to make the mattresses. Then in walls also, because the temperature, it can insulate the temperature heat. Therefore, it has a large variety of usage, and that's why I told that like that. Like it's a conventional polymer.
So why I asked that question is, I mean, this is a relevant problem. And another thing is, now when you in Sri Lanka, in dump site, you might get polyurethane. You know, there are soft forms and the hard forms. So, are there any, like, supposing in a dump site, depending on the the level of whether it is hard or the soft, you may find that the results might vary. So, have you explained that, or you will have to explain it later?
Yes, I'm planning to do the research for other polymers as well, like you have said, for hard polyurethane and also the flexible polyurethane. This is a flexible polyurethane.
Right.
I was planning to do for other polymers as well, because of the current situation, I had a small time period to finish my research. So I'm planning to do in my future.
I think your point about the recyclability is that's correct, but I think there are now people are such system, but the cost is the problem.
Yes.
Okay, thank you.
Just quick question. Your results, experimental results, are indicating pH 9 to pH 11 with high temperature to cause byproducts, which you are yet to demonstrate fully. But then the dump sites are very likely to have a low pH.
Yes.
And won't get temperature is a possibility, but not the pH, right? So two together is what you're saying.
Yes.
At the moment, what the normal practice from a dump site observation is, one is possible, temperature, but not the other.
Not the pH.
Okay. Why do you title these as carbamate byproducts? Just curious.
Because
The one part, right?
Yes, because of the one part.
Okay, but okay, that's little scientific, but people may realize it more, maybe like the polyurethane. I mean, the PUR is the more common, and what's the toxicity related to the carbamate byproducts?
Carbamate byproducts, according to the research articles, I have seen that they are like those carbamates. As we overall get the carbamates, they are used in mainly. I'm not talking about the polymer. This is carbamates. Carbamates are mainly in pesticides, insecticides, and they have also banned from the world most of them because they are toxic to animals and humans as well, because they are renal wise and the immunity wise, reproduction wise, and likewise they are more harmful. They can be affect the health of the humans and also animals. Therefore, overall carbamates are considered as toxic.
This is why now you have got a consumer material. Now there's a pesticide, it's carbamate, you associate with that. When you have the title here, that's a little bit of an issue because, okay, that's heap of pesticides and then, anyway, that's just a comment.
Thank you.
Thank you very much for that presentation. This is the International Conference on Environmental Governance 2021. We now move on to a short break. We'll be back with you shortly. Check.
Check. Check. 1, 2, 3, 4, 5, 6.
Vinok, check. Can you hear me?
Yes, I can hear you. Can you hear me?
Vinok, check. Can you hear me?
Yes, I can hear you. Can you hear me?
Hello, Vinok.
I can hear you. Can you hear me?
Vinok, hello. I can hear you, but we're still
Hello.
trying to fix speakers. Yes.
I can hear you. Can you hear me?
Yes, can hear you now.
You
Vinok,
can
can
hear
you-
me clearly, right? Yes. Testing 1, 2, 3, 4, 5.
Can hear you. 1, 2, 3, 4, 5.
Okay.
Right. Two, three. Vinok, were you able to hear that? The presentation?
No, no.
In your conference, as I move to my presentation, the topic is spatial and temporal.
Vinok, were you able to hear the presentation?
Yes.
Right, great.